Hi there, today I'm going to take you through some graphs of hyperbolas, square root graphs and circles. So three kinds of graphs we're going to look like and their transformations using this graphing calculator here. So we'll start off with familiar territory here, the graph of y equals x squared, which we know, a parabola. Now let's say we were going to shift that, and instead of say y equals x squared, we're going to say the inverse function, which is y squared equals x. So the inverse function is just when we swap around the x and y values in the equation, we get a function like this that is actually just a reflection in the line y equals x. Okay, so we've got y equals x squared, and we've got this curve here, which is y squared equals x. Now, if we do a little bit of rearranging on this equation, y squared equals x, if we take the square root of both sides, we'd get y equals the square root of x. That's the top part. Or we'd get y equals negative the square root of x. So that graph, y squared equals x, is actually composed of two parts. Y equals the square root of x, which is the top bit, and negative the square root of x, which is the bottom half of that graph. Notice that this original function here is a function, but the inverse is not a function. For lots of x values, there's two y values. So y squared equals x is not a function, but if we just take the positive square root, y equals the square root of x, we do get a function. So here's a curve that we should be familiar with. Y equals the square root of x, starting at 0. So the domain is all x values greater than or equal to 0. The range is all y values greater than or equal to 0. You can see particular points on the graph here. When x equals 4, y equals 2. When x equals 9, y equals 3, and so on. When x equals 16, y equals 4. So this is just the square root of x graph. Now what does that look like when we transform it? Let's have a look. Let's start with our basic graph here. Now I'm going to change these values, and we need to know what these do. So firstly, the number out the front. If I make that number out the front different, it changes the steepness of the graph. So there's y equals 3 times the square root of x. So we get a vertical dilation going on here. So rather than going through 1, 1, it's going through 1, 3. There's y equals 5 times the square root of x. So this will now be going through 1, 5, etc. If I change it back the other way, it's going to go on the negative side. So this is y equals negative 3 times the square root of x. So it goes down that way instead of up that way. So that's the value of a there at the front. That's what it does to it. I'll put that back to the normal value of 1. Okay, b, another number inside the brackets here, does a very, very similar thing. So if I change that value of b so it's 4, we also get a dilation, but because of the square root sign, the dilation is not, in this case, going through 1, 4, it's going through 1, 2. Okay, so the dilation will be the square root of as much as the dilation we get with applying the value of a there. So this is y equals the square root of 4x. You could also plot some points as well to get an idea, but it's just good to see, to be able to see what the square root graph is doing when we change that value of b, that number in front of the x. Again, if we go negative, it's going to flip around, in this case in the y-axis. So not in the x-axis, so it's going to flip around. So if we pause it there, this is y equals the square root of negative 4x. So it's a flip in the y-axis. Okay, C. We've done this one before, so when I change the value of C, the graph just moves left and right. So if I have the graph of y equals the square root of x minus 2, it's the same square root graph shifted across two spaces. So that would be that one there, like that. So obviously the domain changes, the range stays the same. And the last one is this plus d on the end. That is just your horizontal translation, so the graph moves up and down. So one question that you might be asked is, what is the equation of the graph given the graph? So let's do one of those. Okay, let's look at this one here. First thing I notice is it's going this way down rather than this way down, so I know there's going to be a negative in front of the square root sign. I can see that it's going through over here at the point 7, 0. That's going to help us as well. So we've got negative the square root of, I can see it's been shifted back this way 2, to the left 2. So I know it's going to be negative square root of x plus 2 underneath the square root sign. So that takes us back that way. And then I can see it's been shifted up 3. So negative the square root of x plus 2 plus 3. And then all we need to do in that equation is substitute in the value of x equals 7 and make sure we get y equals 0, which in this case we will. So here's the equation. Y equals negative x plus 2 in the brackets and then plus 3.